Hi guys, welcome back. So in this video we are going to create an application where you can upload a file which will be stored in this Web3 storage and it will generate an IPFS CID link, and that link is going to be stored in the smart contract which we have written in Solidity. So the application is something like this. You can say it's unique cat, and you can browse the image of the cat and you can submit the query. So it's being written in the Web3 IPFS storage and then in the smart contract, and finally we will get the IPFS hash, that the hash is stored in the smart contract. So let's wait for it. Okay, so the hash is stored in the smart contract, so we can directly go to the docs, retrieve, and we can try to run this link, and we can try to paste this link here, and we can see, okay, so this is the cat image which we uploaded. So this is the application we are going to create. So let's start. Okay, so we are going to go here. We are going to a new terminal. We are going to first run the npm project. In the meantime, I'm going to copy the dependencies which I need for this project to run. So let's copy and paste these dependencies, no, not here, and run npm install. We need some files. First of all, the environment variable file, then we need a backend written in index.js, then we need a front end written in HTML, and then we need a file style.css. I'm not going to write this style.css, so I'm just going to copy and paste it here, and we need a smart contract. So let's wait for these packages to be installed, and then we are going to first write the smart contract, and then we will write the backend, and then front end, and then we will check the functionality of our application. Okay, so the packages are installed, so we can start the first hard hat project, npx hard hat. Okay, let's go to this and rename IPFS hash storage, and let's write our first smart contract. It's contract IPFS hash storage, and we are going to define a struct which is file, and it has two parameters, string file name and string IPFS hash. And then we have a mapping which maps the string, the file name, to the file struct, and it's private files. Then we have a function upload. We are going to give two parameters, the file name and IPFS hash, which we will store in the Web3 storage first. String memory file name and string memory IPFS hash. It's going to be a public function. First of all, we are going to see if files of file name dot IPFS hash is equals to 0, then we are going to say file already exists. But since it's a string, so first we need to convert it to byte. its bytes, and its dot length. So we are going to see the bytes length. If it's 0, then the file is already exist. If it's not equal to 0, sorry. So, and then we are going to say files of file name is equals to file. We will create a new file in the smart contract, file name and IPFS hash. And then we have a new function get IPFS hash, which takes string memory, file name, its public view returns. It's going to return a string, which is the IPFS hash. So we are going to return a string, so it's string memory. We are going to say require. We are going to say the exact same thing here. Let's try. We are going to say that this IPFS hash dot length should be greater than equal to 0, otherwise file not found. So basically what it's doing is it's going to see if the files, this struct has this IPFS hash. If it's there, if it's present, then we are going to return it. What we are going to return files of file name dot IPFS hash. We are going to return the IPFS hash, and finally we have this function of is file stored, its string memory file name, and it's going to return a bool, either a file is stored or not based on the file name. Return bytes. We are going to say the exact same thing here. If IPFS hash is stored or not. If it is stored, then it's going to return true. If it's stored, then it's going to return true, and if not, then it's going to return false. So it's so I think we are getting error here. Bytes of files file name dot IPFS hash dot length, so we don't need this here. So our smart contract is ready. I will just go through all these functions. You have this upload function, which is going to upload the file and create this struct with the file name and IPFS hash. Then we have this get IPFS hash function, which is going to grab the IPFS hash for us. And then we have this simple function is file stored. We are going to see if the file is stored or not. So what we are going to do is we can say npx hard hat compile. It's compiled. Let's run this. Npx hard hat run dash dash network volta scripts deploy.js. Okay, network volta doesn't exist. Oh, I have not copied the configurations, so I'm just going to grab these configurations. This volta testnet, and it taking the private key. So let's do this again. There is one more error in your configuration file. Okay, what is the error? Do we have our environment variable file is empty. I'm just going to delete this address which I have tested before making the video. Let's do this again. Oh, we have this. Okay. Oh, again I need to copy the file from here. So I'm not writing these files in these tutorials because they are just same. You just need to change the name of this contract, and then you just need to copy and paste all these files and then run these commands to upload the contract. So that's why I just copy and paste the stuff from my previous code to the new code, because I think the main thing which I need to make in this tutorial is to write this contract, the backend code and the front end code. So let's copy this smart contract address and go here. So our smart contract is ready. Let's write our front end. So I'm just going to copy and paste this front end here. So it's simple. It's taking style.css and it's creating a div at the top, and then this is header. This is just simple like print commands. And here's the main thing, we have this form. So in this form we have this input which is name of the file, and this is the input type file. So we are going to upload the file, and then we have this button submit, and it's when we click on submit, it's going to go to this upload data. So we need to define it in the backend. So we have this style.css, we have this index.html. So let's try to write our backend. So let's start from the start. We are going to say const express is equals to require express. I'm just going to copy and paste these things here, because these are just libraries which I am importing, and where port is equals to 3000, and then we are going to write app.get, if it's a slash request response, it's going to be an arrow function, response dot send file, path dot join underscore underscore directory name, and index.html, and it's going to be the same thing here, but here it's index.html. And then we will start writing our backend code actually, which is the main, and this is the post request. So anything which is sent from the form which we wrote in the index.html, it's going to come here, upload data, async request response, and this is the function. So first of all, we need to see what we are sending from index.html. We are sending this input, and it has file name, and we are sending this file, and this is the file one. So we can just say where name is equals to request.body. So whenever someone is making a request at the backend, it's coming in request.body dot file name. If you see what is the file name here, this is the file name, this is the input, the name of the file, and then we are going to grab the file, sample file is equals to request.files.file1, this is the name of the file, and then we are going to say file name is equals to request.files.file1.name. So this is the name of the file. So here we need to define a function. Obviously I'm grabbing the file from my PC. Obviously first of all I need to put this file here in my server directory. So I need to define async function move file to server, and it's going to say, it's going to use simple mv command, and here I'm going to use directory name plus a dynamic file name and here we can write the error code in case of error. If error, we can say return res dot status 500 dot send error console.log. If the file is added successfully, we can say file added to the server successfully. So basically this function is going to grab the file from our local PC and it's going to store it here. We are going to test the functionality later, and then we need to upload the data to IPFS. So we can again define a function async function upload data to IPFS. So first of all, we need to define a token which we need to get from Web3 storage. So if we go here in the Web3 storage, I'm signed in already. So if I go to account and create an API token, I can simply name my token testing, and this token is created for me. So I'm just going to grab this token and paste it here. Okay, that's a long token. And then I'm using the docs and how we can store the file. So if you go here, they give you the JavaScript and Go implementation. So here you can import these libraries, and let's say in the Node.js you can import it, and then you can use this function to get the files from the path. So it's also one reason why we stored the file first in our server directory, because we want to grab the files using get files from path, and then we are going to upload it. So basically it's simple. You get the files and then you upload it. So here in the uploading contract, you can say that you can just simply create a client using the token, and then you can simply use put files and it's going to return a CID. So we are going to use the same functions. So let's say const storage is equals to new web3 storage. We are going to initiate a client with a token, and then we are going to say const files is equals to await get files from path. And what is the path of this file? Underscore directory name plus the dynamic file name. This is the file name. It's going to grab the files, and then we can say console.log uploading files to IPFS. Please wait. And then we can say const CID is equals to await storage dot put files, and then we can say console.log IPFS CID is CID, and then we are simply going to return CID. So we have these two functions here. First of all, we are going to move the file in the server directory, then we are going to upload the file in Web3 storage. So now we have the CID of the file and name of the file from here. So then now we can write a function store data in blockchain, async function store data in blockchain, and it's going to take the hash which we are returning from here. So we can say it's hash, and I'm just going to copy and paste the same stuff. So okay, so these are so you need the API URL, private key, contract address, the ABI of the smart contract, the provider, the signer, and finally the storage contract instance. So this storage, after this storage contract instance, this CID, it's bytes 32, so we need to convert it into a string. So we can say let underscore hash is equals to hash dot to string. And once it's done, we need to first check if the file is stored or not. So we can say is stored is equals to await storage contract, this is the contract instance, dot is file stored, and we are going to pass the name. So if you go to this, we can say is file stored, it returns a bool. So we can just say if is stored is equals to false. I mean, if no file is stored, we can say console.log storing the IPFS hash, and we are going to write a transaction on the blockchain await storage contract dot upload name and underscore hash. So we are going to give the name of the file and the string hash, and then we are going to wait for this transaction, and then we are going to say we are going to see what is the stored hash await storage contract dot get IPFS hash of name. Again, this is a smart contract function which we implemented above, and then we are going to say res.send, we are going to send response to the front end. IPFS hash is stored in the smart contract. No. And we are going to show the stored hash So this is the if condition, if the file is not available. What if the file is already available? We are going to say console.log data is already stored for this file name, and we are going to retrieve the data. So again we are going to do the same. So here we are changing the name as IPFS hash, and then we are going to send this response to the user. res.send the stored hash is IPFS hash. So these functions are almost ready. So now we need to run these functions. So if you so first of all, we are going to say await move file to server, and then we need to wait for some time because it takes some time, like 1 or 2 seconds, to move the file from local PC to this server. So we are going to say new promise resolve set timeout resolve 3000. So we are waiting for 3 seconds, 3000 milliseconds. So basically this command, if you want to put some timer in your code in JavaScript, this is the command you need to use. and then we are going to say let hash is equals to await upload data to IPFS, because it's going to return the hash. You see it's going to return CID, so we are storing that CID in this variable. And finally we are going to say store data in blockchain, and we are going to pass the hash. And then we are going to say app.listen, this is the port name, and the function will be console.log. App is listening on port 3000. So our server is ready. We created this server. No, it's not post, it's port which is used. Then we first wrote this post request where we gathered this information coming from the front end. Then we created a function which moves the file to the server. Then we created a function which uploads the data to IPFS, and then we created a function which uploads the data to the blockchain. So let's try to run this code node index.js, and let's try to go to localhost 3000. So it's ready. So let's again write unique cat, and let's go to cat, and let's try to submit query. Okay, we have this problem here, illegal operation on directory IPFS. Okay, I think we made some mistake here. We need to see what mistake we made. File name, async function move file to server, and directory name plus so this is the error we created. I put comma. So let's go again. Let's do this. Let's wait for it. In the meantime, file is added to server successfully. Uploading. So this is the IPFS hash, and now we have this problem of hex string. So let's see what problem is happening here. So this is the API URL, this is the private key, and this is the contract address. So let's see the contract address. Okay, so this is the contract address. Okay, this is fine. Volta RPC, the private key is okay. Okay, so after debugging, I came to know that I forgot to put this command require.env.config. So basically this command allows this index.js files to access these environment variables. So that's the problem I did, and now actually it works fine. So let's go to node index.js, and let's say it's unique dog this time, and let's try to submit a dog file. And in the meantime we can see uploading file move to server, uploading files to IPFS hash. IPFS, please wait. This is the IPFS hash, this is storing the IPFS hash, and finally if we go to here we can see IPFS hash is stored in the smart contract, and this is the hash. So basically if I go here and I go to this link, I can see if the dog picture is stored. So yeah, so the dog picture is stored here. And if I go back to my code, so now we want to test this functionality. If the file is already stored, then it should show the IPFS hash. So we will just go here, we are just going to use the same unique dog, and we are going to submit the query, and we are going to see the file is uploaded, but the data is already stored for this file name, and we get this message, the stored hash is this. So we can again go, we can run this, and then we can again see the dog is here. So basically this was all about it. It has three functions. First it moves the file to the server, then it moves the file to the Web3 IPFS storage, and finally it saves the IPFS hash in the blockchain. So yeah, so that was all about how you can create an application which stores the IPFS hash in the blockchain network and stores the file in the IPFS itself. So thank you very much for watching. Take care. Bye bye.